Welcome to the lecture. This time we're starting a new topic, and we're going to start talking about a Python programming language. This is, by the way, this is not a programming course, so we're not going to go a lot into the details about programming itself and what programming is and all of that thing. That's for you to get that knowledge from some other course. All of you have to take a programming course in the computer science department. So this is not a programming course, but we will touch upon things that obviously deal with programming because we are using a programming language. But Python has become a very powerful and really, really widely used language now, and is very, very popular. It's probably the most popular language at the time right now. So it's really important that you learn at least the basics of what Python is and how to use it. And again, it's one of the other tools that you have for you to use it, and not only in other courses, but also later when you graduate and go on the job hunt. Is a really, really powerful knowledge to have and to offer to whoever you're working for. So let's get started. Python is, of course, what we call a high-level language. It is a general-purpose interpreted programming language, and is interpreted because it doesn't use a compiler like other languages like C or other languages that use a compiler. And then you first have to submit everything in a program, then the compiler compiles the program, put it in assembly and machine language, and then that is run by the computer. An interpreted language is run almost like running it line by line, okay? So it's not as fast probably as the compiled languages, but it is really, really very efficient. And it's also it's got a lot of features that makes it really easy to use and powerful to use. It doesn't require you really understand the details of the computer in order to start programming. It makes that really transparent on how the computer operates. And so that's a good thing. Some computer languages require you to have a real good knowledge of the hardware and the inner workings of a computer. And so this is a good thing about this this language here, that it doesn't really require you to know what's going on behind the scenes in the computer. So you can use Python in a lot of areas, including web applications, big data applications, testing, automation. Is really, really becoming the de facto language in machine learning these days, in artificial intelligence. There's a couple other ones that are used, but really Python is the one that is really dominating the area of data manipulation, machine learning, and artificial intelligence. It can also be used to develop desktop software and mobile applications. So again, a very extensive use of that language. So to start developing a Python program, you first, of course, write Python code into a file called the source code. Then to execute it, you need to convert that code into a machine language that the computer can then understand. So the interpreter in Python is the piece of code, if you will, that turns your source code line by line, one at a time, into the machine code, and then the program, when the program is executing. And like I mentioned a few moments ago, compiled languages, on the other hand, like Java or C, C++, they use a compiler. They compile the whole source code before the program actually executes. So Python is very easy to learn in comparison with other languages. The syntax is very clear and really very well written. Some other programs like C++ or C# or Java are object-oriented programming languages that it makes it a little more challenging to program. And so Python doesn't really have a lot of those requirements. So it makes it very easy to start using it really, really quick. There's not a whole a big learning curve, just actually start using it. He has a large number of users, and it's open source, so all those people contribute, and there's a lot of libraries that available just for about everything. And we're going to take a look at some of those libraries, obviously, because you can't really have the full benefit of Python without really looking into the libraries. It's cross-platform, meaning that the Python programs can run on Windows, Linux, and Mac operating system. And like I said, it's a friendly language. It has a really huge community that contributes a lot to the programming language, again, because being open source. The latest version is actually, I believe, 3.10 is still in beta, but I hear that may be out already. But the real latest version that's been running more commonly is 3.9. And in our case, we're going to be using 3.8, one of the latest versions of 3.8, because I think that's what the program or the system that we're using comes with. So, but there's not a whole difference between 3.8 and 3.9. However, there's a huge difference between version 2 and versions 3. So, I encourage you to use what we're going to use in this class. But if for whatever reason you're using a different system to run Python, a different platform, make sure that you're at least using version 3 or above, but not version 2. Okay. So in order to run, there's several ways you can run a Python program, and there are a lot of tools that you can use. Okay. You can run Python, line by line, like you write regular code in most programming languages, where you just start writing, almost like a text editor, and run it through an interpreter, and then get your results. And that's fine, but Python, again, one of the advantages of Python is that it has a lot of tools, a lot of applications that you can use to run it. And each one of those makes the job of you writing and running the program so easy, or a lot easier, I should say. And one of those systems is called Spider. And the name Spider, as you can see on this slide on the right-hand side, the name really stands for Scientific Python Development Environment. Okay. Is this the system we're going to be using in this class? And I'll show you in a few minutes how easy it is to start using it within this environment. So Spider, like I said, is a scientific Python development environment. It's a free, what is called IDE, or integrated development environment. It's called integrated development environment because it not only lets you write your code, but it has all the features and components that you can use to while you're running or writing your code. And that's why it's called integrated development environment. It's just IDE for short. So it's not, like I said, it's not the only IDE. There are others IDEs, but I think that this one being particularly aimed at scientists and engineers makes it more more friendly and more useful for us, for engineers and scientists. So that's why we chose this one. And there's another reason why we also like this one, and I'll show you that in a minute. So it's an IDE specifically for scientific programming in Python, which makes a huge difference. Okay. And so, like I mentioned, the IDE is really just a software suite that has all the basic tools that you need to write and to test the software. And the core components that you're going to see in Spider are the ones you see here on the screen. You have an editor. You have what is called IPython console, the variable explorer. You have features for plots. You have debuggers, and there's a very good help environment that you can use. And I'll show you the meaning where all of this is located and how we can access it and how we can use it when we're writing code in Python. So before you start, or maybe as soon as you can, I will suggest that you get Spider. It's very easy to get. If you Google it, Spider for Python, or or Spider IDE, you'll get it. You get to the page and download the software. Whether you have a Mac or Windows or even a Linux, if you happen to have one, you can download whatever flavor you want. But just make sure you download the latest version, at least 3.8 something. They may already have 3.9 very soon, but so either one of those will work if you download the latest. So when you do run it, or when you start installing it, you're going to go through the typical installation of these programs. I believe we're going to be using this version 5.33 of Spider. That's the specific version of Spider of the IDE, not the Python version. But I believe that's the one that is the latest at the moment for Spider anyhow. So when you download it, it's a quick download, really. It doesn't take that long. And you run the installation. It's typical installation of whatever program, and you're going to see this type of screen when you start installing it. Once you get it installed, you're going to see this is going to be like your first message here, and your first screen that you're going to see. And it's a welcoming message, and it's going to ask if you want to do a start tour of the environment. And I will suggest you do. I think it's only like 3 or 4 minutes. And of course, I'm going to tell you the basics of it, but I think it's also a good reminder when you start using this. If you take that little tour, or if you look at that little tour of what the features are, okay. Before I go into it, into the environment of Spider, I want to talk briefly a little bit about the language. We're gonna dig in a little more into the actual details of Python, but in order to show you this this program here, Spider, and where everything is located and how you can use it, I want to just introduce briefly a few of the characteristics of Python. Okay. And it's not much different from any other programming languages. And in fact, a lot of the syntax that you're going to see and a lot of the feel for it is very similar to MATLAB, in fact. So in any case, every name, again, that you give to a variable must begin with a letter or the underscore character. Multiple word names can be linked together. Of course, we use the underscore character if you have longer variable names. After the first letter, the name may have any combination of letters, numbers, and underscores. And the name can be of any length, although I don't see the use of really keeping long variable names, but for whatever reason, that's an option. And like in many other cases and many other programming languages, and in the case in MATLAB that you saw previously, uppercase is different than lowercase for the variable names. And again, similar to the other programming languages and in MATLAB, the evaluation of an assignment statement, it happens as a two-step process. The evaluation is first evaluated on the right-hand side. Then the result of that evaluation, or the value, is then moved from the right-hand side expression and put into the variable on the left-hand side, whatever variable is defined. So you create the variable, it creates the variable if it doesn't exist. Otherwise, it's updating the variable, right? So again, typical example, the assignment goes from right to left, right? Just like common programming languages. So first evaluate the expression on the right-hand side, which in this case will give us the value 17. And then the equal sign associates the assignment to the variable my_var. Okay, so again, this equal sign is an assignment type of command. Okay, nothing much different again from MATLAB or any other programming language, as you can see. When you're going to start seeing the differences is, for instance, when you start looking at the data types. Python has some very specific data types. Of course, it's got the typical ones. It's got, it divides them into 5 areas, okay? Numeric, dictionary, Boolean, set, and sequence type. The couple of those that we're not going to dig in a lot, I'll get into that in a minute. But then, of course, the other ones, numeric, of course, is your typical, you know, it's got integer, float, complex numbers. And in the sequence type, we're going to see strings, tuples, and lists. And we'll explain what that is in just a few minutes. And there's also, of course, a Boolean type, which is your typical Boolean data type that handles, you know, ones and zeros, true and false, and so forth. But then you have all these are the 2 types called the dictionary and the set. And we'll explain those in a minute. Those are a little more, especially the dictionary, are meant for handling more huge data sets. And so we're not going to get a lot into using dictionary, maybe, or using set, but we'll explain it and go into it a little bit at least. And we'll explain those in more details in just a bit. And of course, you have your Python keywords, and I'm giving you this just for your reference. Okay, and, these are, you know, names that you cannot use. You cannot name variables with these names and so forth. Okay. Then you have your typical Python operators, you know, typical of most programming languages, really not much different. Again, for your reference. And then, of course, we have the math functions. Okay, and these are, by the way, the functions that come, the math functions defined within Python itself. And we'll explain that in a minute, because there's a difference between what Python has built-in functions and when some of the other libraries have when you run Python. But then again, you're going to find the typical ones, you know, that you find anywhere else. But again, this is again for your reference here. So let me quickly go to Spider, and then we're going to start looking at the environment in Spider. Okay, so this is the environment in Spider. Let me just clean here so that we have a good area to start with. And I start explaining what this of each element is. So by the way, when you first run this Spider environment, it may take a little bit to actually start running for the first time. So don't get, you know, don't worry if you stall it, and then I think it's actually going to ask if you want to start the program once it's installed. And if you say yes, or if you run it for the first time later, it might take a little bit of time before you actually see this on the screen. Okay, so don't worry much about that for the first time, because it takes a little bit to set up everything behind the scene in your particular case. So in any case, these are the areas that that come by default installed with Spider. And what we have here is we have 3 areas. And of course, this can be customized, and I'll show you how in a minute. But basically what you see is 3 areas, okay? You have the editor on this side. This is the editor when you actually write your programs. And you can save them as scripts, if you will. Then you have this area here on the right-hand side that is called the console. Each of those areas here that you'll see in a minute is called a console, okay? And this is where you'll see your output information, for instance, okay? And then you have this area here where you can have a couple of things, like you can see your plots and you can see your variable information. Now, if you pay a little attention, you may notice here that this looks very similar to MATLAB, right? In MATLAB, we have, you know, the text, the script, the area we can write the scripts, right, which is similar to this one. We had the workflow area where we saw the variables, and we have plotting, where we can see the plots in the program. And so in here we have an area that is similar to the command environment in MATLAB. So this is really very similar to the feel of what MATLAB does, at least. Okay. So in this environment, they call this area console area, but think of it like the command area where you're gonna see something real quick as you know, as soon as you type it. So and of course you can change the look, and you can change what you see here on the screen. And to do that, you can go, if you click on this preferences area button here, you'll see that that you have options that you can then customize. For example, one of the things that I customized in my case was the size of the font. And you know, a size 12 looks fine to me. You can also change the type of font. I think it comes with 11 by default, but again, do whatever you want. And you can also change the colors that you see here. This is Spider Dark, again, is the default that comes with it. But as you can see here, it gives you options. On this side, you can see how it's going to look like by choosing the different ones, right? You can see here. I don't particularly like this white one because it, you know, everything is white. But again, if you like it, you can choose this. You can also select colors and settings for the different windows that you see here. So not all of them have to look the same. But here's where you can do this, okay? Here's where you can decide which color you're going to have. Some of this will require you to reboot or restart the program. Some won't. So if I, for example, choose this one and choose apply, see how it changed it? It changed this to Windows. This one didn't change. I can change this one too. And you know, if you want to change it also in the customization. But see how we changed this? Let me choose another one just to show you this rear. Let's choose apply. Again, see how we change, you know, the colors. And it may, you know, some of those might work better for your computer, for the type of monitor you have or whatever. So, you know, you can choose them as you want. I think this one will require you to restart the program. See, this one says, do you want to restart? Of course, I don't want to. But so whichever you want, whichever you like. I happen to like the dark one that comes with, you know, like this. So, but it's your choice. So, any case, you can change other things in here. I'm not going to go into all of those, but you know, you can change some of the things you see in the editor area and so forth. Again, it's your choice. Okay. Other thing that you can do also is if you want to change, if you look at the view here, you can change the panes, right? what panes you're gonna see in this area. I like the default one, but as you become more used to using this, then maybe other panes you may want to see, other windows you may want to see, that you may want to have available right away. And it's going to be up to you really to have them available to you. So for the time being, I will suggest you leave it as default. And as you become more and more familiar and comfortable in using it, then you can start playing with the customizations. Okay, because if you do a customization and it messes something up, then it's gonna stop you from actually start using it. So anyhow, that's my my advice here. Some of the things you can see here, for instance, right away, like I said, this is like the console, the command area that we have in MATLAB. Let me close this so I can start from scratch again. Okay, so let me close everything. All right, so we're clear now. Some of the things you can do to control what you see, for instance, you can start using it like we use MATLAB before, like a calculator, for example, right? So 6 plus 7, you get the result and so forth, right? No big deal. You know what that is, right? In this case, the interpreter is acting as just like a calculator. You can type the expression and it will write the value like you saw. And the syntax, again, is very straightforward, right? You have your plus, minus, and so forth, signs, just like in most programming languages. You can use parentheses also for grouping things, or grouping numbers, and just start typing numbers and it'll give you those results. If you're using integer numbers, you get an integer result like I did in this case. If I change that, for example, to a floating number, then the result then will be written as a float number. Okay, if you use division, like so, you're gonna get a floating point number as a result. So the integer numbers, of course, have the type int, and the ones that have the fractional part have the type float. And we're gonna see more about this numeric types a little later in these lectures. The division, of course, always returns a float. To do floor division and get an integer result, you can use the double operator, the double /. So, for example, if I do the classic division, I will get a number like that. But if I do double the /3, then the result will be just the integer part. Okay. Of course, if I do the percentage sign, it'll give me the residue. Oops, I'm sorry, I made a mistake. 17. I want to do %3 in this case. And of course, I get number 2, right? So those are some of the things that you can do. You have your square. If I want to square a number, it's 2 times the asterisk, and then you get your results. 2 to the power of 7, for instance, is 128, and so forth, right? So that's the area that you can use to either test some of the commands, but this is the area where you're also going to see the output, just like MATLAB, if you remember, right? There's also a couple of things that are useful here. One of them is if I want to clear this area here, I can use the command CLS, and CLS will clear the screen, like you see, right? So just do CLS. You can also do control L, control plus the letter L, and that will clear the display as well as a command if you want to do that. And of course, you can assign numbers to a variable, like in MATLAB or any of the other languages. So if I do A equals 5, it assigns 5 to A. If I do B equals 10, B has a 10, and so forth. And you can see here on the area at the top is the variable explorer, right? The variable explorer is like your workflow in MATLAB, right? And you can see now at this point your variables and the values that those variables have, and the type and the size, right? A little more detail actually than MATLAB, because MATLAB doesn't automatically give you the type and the size, or at least it's not that obvious as it is here with this environment. That's very easy to use. You can also do things that Python allows you to do. For example, if you have a very large number, let me just do large equals, and you can write a very large number by using underscores. So if I do, for example, 15 underscore 3 threes, another set of threes, zeros, and one more, right? Python recognizes that as a number that you're just building. Of course, I'm not going to write it here because I haven't done anything to write it, but you can see here in the variable, it has assigned that number with 9 zeros in it, right? By typing that. And the reason they do that is because it makes it a little more readable. Like if you have a really large number, especially if they're not just zeros, right? Let's say something like, let's make some. And let me assign that to just another variable X. And to look, and of course you can see how that looks in the variable area. But I can also use a simple print command, and if in Python, just like in many of the other languages, there's a simple print command. And if I put what I want in parentheses, and in this case I want to print just the value of X, then it'll show me the value of X. If I want to do more than one, I can also use comma, and if I use comma, and then the other variable that I have is LRG. And then it'll print both of them, right? Let's see, there was something else I was going to mention here. Okay, so that's the command for doing that. It's very easy, right? I was going to say, if you have something in quotes when you're printing, then it'll interpret that as a string, right? So if you put in double quotes and in parentheses, it interprets that as a string type. So and Python doesn't make a difference whether you use double quotes or single quotes. It'll still print the information if you use just single quotes. Okay, so it doesn't make a difference. The other thing also, just like in MATLAB, that when you use the arrows to go up and down in the command window, in this case in the console window, you can look at your previous, the previous commands that you put in. Say, I'm going up and then going down, so you can see the other previous commands that you had. Okay, so so this is the console again. This is where you'll see the output information, and you can use it like a simple command line, right? If you go back again, one more thing, we can also get rid of or clear the variables, and there's a couple of ways you can do that. Let me do this again. If I want to clear the variables here, I can do it using the command %reset. If I do %reset, it's gonna ask me, you know, do you want to proceed with erasing or getting rid of your variables? And of course, at that point, you say yes or no. If I say, I'm gonna say no, so I can show you the other example. Nothing is done. The other way you can do it is you can do the same thing. You can do %, but in this case, if you do -F, it's not going to ask me. It's just going to do it. Okay. So %reset without the F, the -F will ask you if you want to get rid of the variables. But %reset with the -F, it's just gonna do it. And as you can see, I don't have any more variables here. It got rid of the variables. There's another way we can do that, and let me just create a couple of the variables here, just to have something in the variable explorer. And the other quick way of doing it is just by clicking this icon here. See when it says remove all variables from the kernel workspace or namespace. If I do that, again, it's going to ask me. You can choose to say don't show again, right? And then it'll be almost like doing the reset -F, because it's not going to ask you again. It's just going to do it. So maybe let the program or the system keep asking you until you really feel comfortable with how to use it, because you may want to have variables that you don't want to necessarily get rid of. So that's why you do it. If I say yes, it's going to remove it, right? So it removes the variable. Now I'll show you something also a little later, after we look at the text editor, and that is something that is different, right? Because here you see one command window or one console. I mean, at the time right now, but I can have multiple of them. Okay. And I can assign multiple consoles to different scripts, for instances, and that way I can keep them really separated. I can keep them really organized, and I'll show you how that works in a minute. And so, if I move over to the editor side, I can start writing. I can just start typing a script, a program, right? Comments in Python are denoted by the use of the hash or the £. So anything that follows that is a comment. Okay. So of course it's ignored, and then from there you can type your commands and start writing your script. So if I do C equals 4, D equals 9, and if I do, I'm going to say another variable, X is equal to C to the D power, or I'm sorry, to the D power here. So I'm going to do exponentiation. And of course, you don't see anything on this side, but as you notice in the program here, right? There's a few options that you have, right? You can run your script, right? Again, very similar to MATLAB, right? You can choose to write portion of your script, and this will be the button that you use. So for example, if you have a huge script and you just want to run that portion of your script, you will choose that. If I want to run the whole thing, and let me clear this console, by the way, so that we can see more clearly what's going on. So if I run this, and I'm going to choose to run it, right, you'll see that I didn't print anything, right, but it ran because you see here that it created the variables, right? So I'm going to add a quick print statement, and I'm just going to say print the value of X, right? and I'm going to run this again. And now, of course, it prints the value of x, see, right? And again, it created those variables that you can see here, right? So whatever I'm doing on this editor here is going to show on this console, okay? If I'm writing a different script and I want to have a different console to show it, so let's say that I make changes to the script and I want to run it or I want to see it on a different console. Then if you look on this area here under options, and there's a choice here that says new console with default settings. So if I click on that, it's going to create a new console. And then I can change the name of it. If we double click on it, you can change the name of it so you can actually associate that output or that console to the script that you run. And what that means is that whatever is live here, whatever I have here on the editor is what's going to show at the console here. So as you can see here, there's nothing, right? If I make a change and now I said print, and I'm going to just say this is the output, and of course I need quotes, either single or double, it doesn't matter. Okay, and nothing happens, right? Because I haven't run it. I'm not doing it live, but if I run this again, now it says this is the output, but it's putting the output in this console, not on this one. See, this one still has the old output, the old information that I was running, but this one has the new one. So again, whatever you do here, you can choose to select different consoles, different areas where you can see the output. And this is also nice because it allows you, for instance, to run multiple things at one time and keep the results in different areas. So you can, like if I make a change, if I have a huge script here and I want to compare the outputs from one to the other, I can keep the outputs separated by putting them in different consoles, okay? And you can keep adding consoles, if you wish. New console, and just add another one, and as soon as it shows up as a tab, you can start whatever is live here, and you can go back, and choose. If you don't want to use the console, you can go back and choose like the first one again. I can run it, and again, it's going to be live, so it's going to change whatever console I have live associated with this script. Okay, and to add a script or to create a script, I just choose this icon here, and as you can see, it just adds another window, another pane where I can start writing the script. And you can choose to, when you save it, change the name, or you can choose to delete them, right? And to create more if you want. There's other things you can do with this, and we'll get into that later. Some of the other options you can do with this with the editor area, and we're going to get that in a little bit. Okay, so let's go back to a little bit to the PowerPoint slide, so we can talk a little more about some of the other type of data that we were mentioning just now, data types. All right, so we were talking about the different mathematical functions available, and then what I'd like to continue talking now is into one thing, into the libraries that are used in Python. Okay, the use of libraries is not a unique feature to Python. Okay, a library is just a collection of code that makes it easier just to run more efficient the code that you're writing and using like a standard functions or definitions for your own purposes. But the advantage with Python is that it's very extensive, and it's got a lot of very specific libraries that you can use for specific applications. Library in general have built-in modules, like the ones in MATLAB in Python are written in C, and it gives you access to system functionalities such as file input output that otherwise it will be very hard to either write or to get access to when you're programming. And you can also have access to modules that are already tested and designed for specific problems, for specific applications. And again, this is nothing new. We saw this in MATLAB, right, where just about anything that you use, if you use the sine function or any other built-in function, is really written behind the scenes. So you're really using a library, right? One of the other differences is that with more extensive or more specific applications in MATLAB, you either have to pay for those specific modules to add it on to MATLAB. For example, MATLAB has extremely use of other modules that can be used for specific applications, and is very, very, very powerful, like telecommunications, robotics, and things like that. But you're actually paying for that. If you want that, it's really extra to whatever you pay for your MATLAB basic MATLAB application. In the case of Python, though, you can do pretty much the same thing, but you're not paying for that because you just use the libraries. The libraries are open source, so the code is free, and you can basically use them, the ones that are available as open source. And so some of the modules that you're going to see in Python are explicitly designed to make the program really portable, right? In other words, you can run it in any platform and any operating system that is available. And that's another thing, that you're writing something that is not only going to run for your specific operating system, but it's also going to run for any operating system that Python supports. A program must import a library module before you start using it. Okay, and this is true for any computer language, but I think is a little more obvious in Python. But if you already program like something in C or C++, you remember that before you can even start running your code, you have some of the pre-code lines at the beginning of your program that are really importing things that you need to run that program, right? So that's what a library is. But you will see here a little more obvious, because the applications are just so vast. Okay, so to start using the library, you use the import command to load a library module into the memory of the program. Then you refer to things from the module by using something like module underscore name thing, period thing in the name, and I'll explain what that is in a minute. Because Python uses the period to mean the part of. So that means that if I have the library name, it'll be the module name of the library name, and whatever is in that library that I want to use, right? For example, let's just say I'm using the math library. So the module name will be math, and I will follow it by a period, and whatever I want to do with that math. For example, math period sqrt will mean that I want to use the function square root from the math library, right? So the dot indicates that particular thing that I'm using from the library. With the libraries, you import specific items to make your program short, right? So you don't have to deal with all the definitions of what the library has, or all of that. It's really transparent to you. And so you can use from, and then import, to load only specific items from a library module. And this is a good idea because if for example, if you have a big library, right? Some of these libraries are huge. And when you import that library, the code that runs all those libraries, that has that information, is really occupying the memory in your computer. So if you just start dumping libraries into your programs, your code is not only going to be very inefficient, but your computer memory is going to run really, really low. So it's always a good idea to be careful what you're really loading into a program, so you don't start running out of memory. And only use the libraries that you really need, and then the format that it says here. And we'll see some examples in just a while here. You can create an alias for a library module when you import it, again, to shorten the program. And this is a very, very widely used convention among Python programmers. Okay? And there's some specific names, aliases, or nicknames that they give to the libraries that are commonly used by most programmers. And you'll see some examples of that in just a minute. And to do that, you can then import your library. And when you say import whatever library name as, and then you give it the nickname you want to give that library, right? So you can import a library that is already existing, available for Python. And when you say as, then you give it whatever name you want to give to that library, right? You give it an alias, a nickname. And again, there's some that you can probably just use whatever name you want to give it, but there's some other ones that are kind of there's a kind of a rule of what commonly programmers will name that library. We'll see those in just a minute. So once you give it a short name, the alias or nickname, then you then refer to the items in the library using the short, the short name with a period following, or whatever you want to use on it. In the case of Python already comes with a math library. Okay? This is the math standard library. It has your basic functions that we just saw a few moments ago in the slides for your basic mathematical operations. And to use it, you simply do import math. Okay, when you start writing your code, you say import math, or you can also say from math import, in whatever import whatever area in your program you want to put that in. It'll import the math library. Now, there's another third-party package that also include the math functions that Python has, but it's got even more than just the typical or the basic math functions that you're going to assign in Python, and it's called NumPy. NumPy is really, really, really popular among scientists and engineers because they use it for a lot of programming applications. And if you're using numerical or vector operations, is really the library to use. I think most developers, most people writing code for machine learning or for artificial intelligence use NumPy as the #1 library for scientific language applications. So NumPy stands for Numerical Python. It's an open source Python library that is used again in almost every field of science and engineering. It's the universal standard for working with numerical data in Python. And it can be used to do a lot of mathematical operations on arrays. It adds really powerful data structures that makes your program run more efficiently with array matrices. And it keeps evolving. It's always changing because, like we said before, there's a great community that are always adding more and more features to NumPy. And it's free. And to use it within your code, all you have to do is say import numpy or numpy, sorry, as. Okay, so this is the format that we were seeing before, right? When you say import, right? You import as, right? So all you will do in your code say import, and it's importing this library, and it's importing it as MP. So what this is you're shortening the name. So instead of using numpy in my code from now on, I'm only going to refer to it as MP. Now, you can call it whatever you want, numpy, you can call it NPY, whatever you want to call it. But what I was telling you before is that this is almost like a known fact that most programmers recognize NumPy as NP. It's just become the de facto nickname for NumPy. So get used to some of those cases where, for example, if another programmer sees your program anywhere and it sees inside the program it says NP, they know exactly what you're referring to. Okay, and that's the idea. So some of this have, even though they're aliases and you can give it any other names, some of those are already predefined as to, what's the convention that you should be using. So the advantage also is that NumPy arrays are faster than Python lists. Python uses lists, and we'll see what lists actually are in just a few minutes. And again, NumPy uses arrays, and that makes your program run faster because of some of this reason. An array is a collection of homogeneous data types that are stored in contiguous memory locations. You probably remember this. It's the same idea behind what is used in MATLAB. On the other hand, a list in Python is a collection of heterogeneous data. In other words, you in the use of lists, you can mix different data types, okay? And those data types may be located in non-contiguous memory locations. Now you can think how this will make programs run not as efficient, because in the case of arrays, it's not only required that the data types have to be the same for the information that is in the array, but it's also the arrays are stored in contiguous memory locations. So as you can imagine, when you're running this, that the computer, the CPU, runs a lot faster because it doesn't have to move around to find where the list data is. Because in the case of Python lists, they may be stored in non-contiguous memory locations, right? So that's one of the reasons why arrays are more efficient. List is used to collect items that usually consist of elements of multiple data types, like I said, and we'll see some examples of this a little later. So with a list, again, you can have integers, strings, floats under the same list, right? An array, you can't have that. You can only have a specific type. An array is also a vital component that collects several items of the same data type. The lists are capable of performing mathematical operations, but again, they are less efficient in comparison to arrays. With that brings us to, again, to this point here, that if you're using the math libraries in Python, yeah, you can do a lot of what NumPy does. Not as much, though, because NumPy has a lot more applications. But one-on-one, in other words, if I use the sine wave, the sine function that comes with Python, or if I use the sine function that it comes with NumPy, it's more likely that the one that comes with NumPy is going to run more efficiently, because of the fact that when I use it, when I use the sine function or whatever other function, I'm going to be using arrays in NumPy, okay? But by default, Python uses lists, so that that difference will make the program a little, less efficient than with NumPy. So that's the idea behind NumPy, okay, as being more efficient. All right, so let's take a quick look at what lists are, and then we're gonna see some examples a little later. But let's look at the definition at least of what a list is. So lists, a list is a combination of items separated by commas and they're enclosed within square brackets. The values that you can store in the list can be accessed using what's called the slice operator, and we're going to see some examples of this, with indices starting at 0 in the beginning of the list and working their way to the end with a -1. In another difference between the MATLAB language and Python, one of the differences is that, if you remember, in MATLAB, the first index of an array is always 1, where in Python, the first index of an array is always 0. And that's really the common the common notation in any programming, most programming languages, especially scientific programming languages, C and Java, all those programs, the first index is always 0, right? So Python is no different. So that's one change here, that Python indexes starts at 0. And if you want to access the last one, or as you go from the last one towards the first one, you use the -1 number, and you'll see examples of that in just a minute. The plus sign is the list. It uses is used to concatenate different data types or different data into one, and the asterisk is the repetition operator for lists. Again, we're going to see examples of that a little later. The other type, if you remember, when we looked at types for sequence types, or we looked at lists, right? Strings are, what strings are, right? That's, characters, right? Those really don't require a lot of explanation, right? But the other one that we're going to define is the tuple. And that's a commonly used data type in Python. Tuples and lists. So the tuple is different than the list, as we'll see. And remember, the main difference or the main characteristic of a list is that it can have different data types, okay? The tuple, however, is another sequence data type that is similar to the list, and it consists of a number of values also separated by commas. And by the way, it's not here, I think, but oh yeah, it is here. Unlike lists, tuples are enclosed in parentheses, within parentheses. So list, if you list, if you have data listed as a list, you're gonna put it in brackets like this, square brackets. But if you put it in parentheses, Python is going to understand that this is a tuple side. Data type, okay? And again, if you're just dealing with numbers, it won't really make a big difference, other than you can mix the type of data numbers you can have in tuples, in lists, but not in tuple. In tuple, you can have the different data types. So lists have what's called mutable nature. In other words, lists can be changed or modified after its creation according to the needs, whereas the tuple has immutable nature, meaning that once you create the tuple, you can't change it or modify it after it's been created. Also, lists have variable length. Tuples have a fixed length. Lists have more functionality than tuples, but they'll have, they have different uses, as you'll see a little later. But again, the main difference here is that once you create a tuple, you can modify. You can't change it or modify it after you create it. List, yes, you can. And we'll see examples of that in just a minute, or maybe in the next lecture. The other data type is the set. Now, the set is a little more, I guess, challenging to use. And to be honest with you, I don't think that we're going to be using a lot of sets in this class. In many cases, this and dictionaries are used when dealing with huge amounts of data, mainly like for artificial intelligence or data type, huge data type operations. But a set is an ordered collection of data that is iterable, mutable, and has no duplicate elements. Okay, that's a mouthful, right? Iterable means that it can be looped over, or you can iterate through it, right? Go around the loop with it. The order, what makes this a little challenging is that the order of the elements in a set is undefined, though it may have different elements. Sets can be created by using the built-in set function with an object or a sequence by placing the sequence inside curly braces and separated by commas. So you can start seeing the difference here, right? Lists uses square brackets, tuples use parentheses, and sets will use curly braces. The type of elements in a set don't have to be the same, just like lists. They don't have to be the same type. You can have various mixed up data type values in the set, and set items cannot be accessed by referring to an index. They're not indexed, and the reason for that is because they're not ordered. When you put something in a set, it doesn't keep an order, and we'll see examples of that later when we look into some examples there. But for now, just keep that in mind that you can access a set element by using indexes, because it doesn't use index. Because when it saves the data, it can save it basically in any order it wants. Okay, that's the idea. And so when you retrieve it, if you just retrieve it randomly, the data is not going to change, but the order that you see the data may change, and you'll see that later. You can loop through the set items using a for loop, or you can ask if a specified value is present in a set by using the in keyword, okay, the in keyword. And we'll see examples of that later, okay? So the integer, the float, and we haven't seen complex numbers yet, but we'll see some examples later. But these are your typical ones, right? The normal ones that you've seen before. You have the Boolean ones that you also see before. Same thing. This are maybe probably new to you, especially if you haven't done any sort of like data structures. If you have taken some data structures, you may already be familiar with this, but if you haven't, that's okay. But this may be newer to you, and we're gonna show some examples of this. Not the strings though, because the string is just what a string is, right? Just characters basically. But we're gonna try to at least see the difference between a set, a list, and a tuple by looking at some examples later. All right. Okay, I think that's all I have, and I'll see you in the next lecture.